All right, this is chapter 10, climate change. All right, so climate can change for many reasons, like the ice ages with the Milankovitch cycles and all that we talked about, and the amount of solar radiation that's hitting the surface, and that changes from the energy from the sun and the sunspots to the tilt of the axis and everything else. The position of the continent through time can also affect climate change. But right now, the main focus is on the greenhouse effect because we are not sure how much people can contribute to these global changes. I think the data is starting to support that people can have a large effect on climate and our global systems. Although we think we're so small, we can't. We are actually quite a force on the planet. So the greenhouse effect. So how that works is there are gases in air that kind of hold in energy and heat. The main ones are methane, water vapor, and CO2, which is carbon dioxide. Um, so they trap the infrared rays in the atmospheric gases, especially as due to the increased concentration of carbon dioxide derived from burning of fossil fuels. So since we've been burning fossil fuels, we've had an increase in carbon dioxide since that's one of the greenhouse gases. Um, on like the chalkboard, the equations show that the carbon dioxide is going to contribute to this greenhouse effect. When it first came out, people weren't really sure if yeah, it makes sense on the chalkboard in this very limited equation, but we're working in like an open system. There's all these other variables. Maybe it won't really happen. But now we're decades in of collecting data, and the data is starting to really support that yes, there is a link between carbon dioxide and temperature, and even more so, a link between the carbon dioxide we have introduced into the atmosphere and temperature. So here's just a little image of that showing the radiation coming in. It bounces back. Um, and instead of just reflecting out, it'll reflect off of things like clouds, off of ice, will reflect it. Um, but the atmosphere will trap it. And the more methane, water vapor, and CO2 you have, the more it's going to trap it. Like other planets, and I'm not like a planet person, but other planets don't have an atmosphere, and that's why they don't have, like, it's freezing. Even if they're closer to the sun, they can still be freezing because they just don't have an atmosphere to provide this mechanism. Um, so okay, yes, and then the analogy of it's like a greenhouse. When you go into a greenhouse and it's hot, and that's because same thing, like it's a very much closed system, so all the heat coming in through the glass, the heat comes in, but then like it's like the sunlight comes in, but the heat can't leave and it gets trapped. And it's that same principle with carbon dioxide. Here's a chart showing the increase in CO2 since 1960, which is all pretty much human induced. Yes, volcanoes can release a lot too, but that's not a continuous and not a continuously increasing um, phenomenon, where us using electricity and driving around in cars obviously is. And it's quite a pickle we're in again because he wants to stop using electricity and driving cars and going back to being like a third world nobody. So it's like darn, what do you do? And then here's just this is the difference in global mean temperature since 1880, where you can see from 1880 to about 1920, it was actually cooler than average. And I don't know on this graph what they're calling average or how they calculated that. I do not know. Um, and then since about 1920, it's been getting warmer than average. So what are some results of a warming world. Well, the ice is going to melt. If all the ice melted, sea level could rise by 60 to 70 meters, which is about 200 feet high, which is really kind of a lot if you think about it. Just from the added water alone, not even including, so that's just that doesn't include like how warm water takes up more volume, is what that's saying. About 20% of the world's land area would be submerged. And we've already seen this. I mean, how many times do you see like these ancient civilizations are found on these coastlines that have been submerged, and divers and archaeologists are finding these old things under lakes or oceans, and that's all we are still coming out of the last ice age. So even before people started putting CO2 into the atmosphere, we were coming out of an ice age, and the ice has been melting. So we're finding now, like, oh, yeah, this used to be the coast, and there was a city here, and it's just been underwater like since modern time, and we didn't know that that existed. The whole Atlantis concept. Um, let's see, many millions, perhaps billions of people now living in coastal or low-lying areas would be displaced, and we've already talked about this, but again, those divergent passive margins, and you get some really big cities. I mean, New Orleans, Miami. Charleston. I mean, these are not little tiny towns. I mean, these are millions of people that are going to be out of homes, businesses, and everything. Um, Here's an image showing Greenland and Antarctic ice sheets. That Greenland is actually losing. Okay, so red here is loss, white is about steady, and blue would be adding ice thickness. Or ice mass, not necessarily thickness, but probably thickness. Um, so Greenland is losing much faster than Antarctica is. Here is a shot of Greenland from, what is this, the median ice edge between 1981 and 2010, because it's going to change annually. So the average within that about, what, 30 years was about here. And so here's what it looked like in 2021 and then in 2022. So you can see again the annual difference, like this was here the following year. So it looked like it grew between the 2 years, but overall it has shrunk. And then here's just the amount of Arctic sea ice extent. And you can see it's definitely decreasing. Besides the ice sheets and the glaciers, we have permafrost, and this is essentially where the ground and the soil is frozen. Relatively recent new find, because like the soil on the top, I think, is still kind of thaw, but then as you dig down a couple of feet, it's frozen. This is where they're finding a lot of those old findings, like, hey, it looks like it's, like, oh, we recovered this mammoth and it still has fur and stuff. That's because it was in the permafrost. So it was buried, and it wasn't buried in like a glacier, although some of them I think have been. Some of them have also been buried in the soil, which is the soil has been frozen since the Pleistocene. Um, and so that's thawing out now. That's also releasing a lot of methane and other CO2, like other greenhouse gases it's releasing as it's thawing out. It's a positive feedback loop, which we'll get to. Um, Let's see, being losses along the north of the Alaska, melting permafrost and loss of protection from waves has led to the collapse of coastal cliffs. And so, because it's frozen, it's kind of like the ice that's holding everything up in a way. So then, as it melts, it's just becoming blah, if you will. You can just imagine how that would look. Um, like strain abruptly when the last of the ice below melts away again, because it's like the ice was holding it there, and so then when there's no more ice, it can just seep into the ground. All right, and we're going to stop there, and then we will go into oceans.